So okay. Lihuy and Menghout.
Yes, miss.
Yes.
Yes. Okay. So when you start your presentation and when you add your questions and answer, can you kind of put something on the screen that people know that when they are come in that you kind of meet you still there and willing to kind of answer questions because sometimes it's very quiet. People jump in and they don't know exactly what is going on in your room. Okay.
Yes, miss. I can do
Yeah.
that.
Okay. Yeah. Okay. So let's give another couple minutes and then you can start. Okay.
Yes, miss.
Yeah, I think you have Saxon here and a couple of people in. Yeah, you can ask them if you can start to. Okay, just keep your audience with you. Keep audience with you. Okay. Okay. Okay, I think you can start now. Even you have one or two audiences. Okay. Okay. Yeah. So, Lihuy and Mengwat, you can start. Yeah.
Yes. Good afternoon, everyone. So we will start our presentation. Yes. Yes. So hello, everyone. Welcome to IT Day. So this is one of our final year project related to license plate localization and recognition. So this is our content for today. We will introduce you what the topic is about and show you why we need to build this project. And then we will go to like our tool and library that we use to build this project. And then we're gonna give you a summary of how we approach uh, to build the method that we use to build this project, and as well as we will uh, talk about the future work as well as show you the demo. Yes. So license plate localization and recognition. Another terminology is ALPO, which stands for automatic license plate recognition. It is an image processing technology that identify the plate number from vehicle automatically. Yes, and ALPO is a very challenging area. There are two main problems. There are two main areas that related to this type of system. First one is object detection, and second one is character recognition. Yes. So here is a short video that show you one of the use case that they use ALPO in Western country. So this car here will get scanned by the ALPO camera, and then process through the system. So it will verify that if this car is eligible to go into this site of area or not. If if the car is registered, it will open the gate and let the car go in. Yes. So so why we need to build this type of system for Cambodia license plate? So as in the foreign countries such as United States, Australia, or Canada, they use this type of system to like for toll collection, for managing the parking space, as well as for law enforcement purposes. Such one of the use cases is that metropolitan police department, like in the U.S., they use this system to track criminal or suspect or even a stolen car. So, however, for Cambodia, we haven't like exploited or used this type of system in our road. So, as for parking, which like if we go to local market or like where we used to park, they usually hand out a handwritten ticket. This, however, doesn't benefit much the owner because they can they print their own ticket or give false number to the owner, so that the owner will lose profit. From what I experienced, that they reuse the old ticket and like they give to the customer. Yes. And also like if there are cases like hit and run or you lost vehicle, if you report it to the police department, like it take them very long time to like to track down the suspect or where the vehicle is, something like that. So as such, we want to build an ALPO system that work well with our local plate. So this is our tool and library that we use. First off, we use Python, which is a top level language. So we use this language because like we are very familiar with this one. Also, for library, we use Kairos, which is a deep learning library, allow us to build a complex model in a very fast time. Yes. Also, we use Tesseract OCO because Tesseract OCO, which is an optical character recognition, because we don't have enough time to build our own OCO. As well as we use OpenCV for processing the image. And the last one is label image, which we use it to label our data to fit into our detection model. Yes. So next, I will hand it over to Mr. Lihuy. Will present you about the GUI and how the detection works. Yes. So he got connection error. So I will go over the GUI here. So. So as you can see, this is the left side here is the data flow of this application. So if you open this application, you need to select a file, and then you click start button, and then it will take the image here, and then proceed it to detecting the plate image. If the the plate is detected, it will feed forward to the OCO, Tesseract OCO, which will extract the license plate number and place it into this box here. Yes. So for this this import box here is the original image of the file, and then the output here is the output from a detection network, which is a cropped image of the license plate. Yes. So I will hand it over to Mr. Lihuy. Oh. Yes.
Yes. Is it demo time?
No, detection time.
Okay. Yes. Wait a minute. Can you see my screen?
Yes.
Yes. Yes. Can you see the slide?
Yes. I already go over the GUI. Yes.
Yes. So about our detection, throughout our license plate detection and recognition project, one of the main problems that we have come as our main challenge is the data collection. However, we wrap around the problem by using a mixture data set using Cambodia, Western, and Chinese car image. And all this image has to be labeled so that we can supervise into our into our project. As you can see here on the left image, we have the raw image of the car, and the right hand side we have the label image using the two mentioned earlier. And here is the architecture of our network. We have two main network for detecting the license plate area. First, we have the region proposal network, shortened for RPN. The region proposal network have two output. One is the classification, whether the object is a license plate or not, and the second one is it a coordination. And the network will optimize or learn from the image that which a location actually contain the license plate using this formula. Yes, and train on our data set. Yes. And the second one is that when we have the object location, we will feed forward it into the next network, which is the regional convolutional neural network, or RCNN. And this one also have two output. First one is they will label the class to the object, that is it a plate or not, with a probability value. And the second one, it's a coordination. Yes. And for the recognition part, yes, I will hand it over to Mr. Menghout again.
Yes. So yes, I will continue from Mr. Lihuy. For recognition, we use TestRec, which is one of the best OCR engine. So TestRec is built by Google, and it supports more than 100 languages out of the box. So to implement it in the Python, we're gonna use PyTestRec library. So there are some limitation of TestRec since it is a free engine or product. So first one is it doesn't work well if the image is small, or it could include a very complex background. And another case is if the text is skewed or not aligned. So the second limitation is not capable of recognizing handwriting. It will output poor result when the image contain like two or more language. This happened with our plate number, since we have like two language in the plate. Yes. So as you can see here, one of the testing that we try ourselves. So as you can see, if the image contain like a small dot here along the top line here, it will produce a very a very bad output. As you can see, it produces accurate tesseract, which is not correct. However, if the image contain only the text, as you can see, it is very aligned.
I cannot see your screen. Yeah, I
Oh.
can see your screen. Yeah.
Yes, I also cannot see your screen. You forgot it.
Why don't you tell?
I don't know.
Yes, so I will go over again. So this is a recognition example that we found it condition that it is not working well with the tesseract. So as you can see, the left image here contain like a white dot, 3 or 4 or 5 6 with the small number, the small like noise, the tesseract perform poorly. As you can see, it produces a very different output for the first word. However, if the image contain only the text with no noise or environmental background, you can see it produces a very accurate result. This leads us to do some image pre-processing to enhance the image quality. So it will like reduce some error. So first we enhance the DPI image to 300. So you can see here, this is 72, 150, 300 DPI, which means that there are a lot of pixels in the screen. As well as we convert it to grayscale image, because if we use like a normal color, it contains like RGB, so it will be hard to, it will take a lot of effort for the engine to predict the output. If we convert it to the grayscale image, it contains only like one channel, which is gray channel, or just since the number will be all the same. So yes, so here is the some example that we tested. So the small image here is the result from our network. So if we get this type of image from the network, it will automatically plug it to the tesseract OCR. However, if like as I described it, if the image is skewed or contain a lot of noise, it won't produce a very good result. So along this image here, only this first this bottom middle one produce the right output, because like it contain no background, and the text is not skewed. Yes, I mean it means that it aligned properly. So after many times of testing, we found that the left side image here, any type of data that resemble this type of image will produce a very good result. However, on the left side here is it may contain a lot of background, the text is skewed, and something like that. The tesseract will produce a very poor result. So, like in conclusion, we can say that we have satisfied our goal here, which is an LPO system that works well in detecting the local plate. However, there are some limitations in we have no control of the tesseract engine. That lead us to in the future that we want to improve this limitation by building our own OCO network. Or another solution is that we cannot find a good way to pre-process this type of data. But to do it automatically is very, very challenging, since the image is like very various angle with various shape or position. So also like we want to like extend this project to be a very useful product, such as a packing system. It will like automatically detect the plate when the car go in, and you can count how many vehicles in the parking space. And also another use case is we can build it to like for law enforcement purposes that will be used by the government. Yes, and this is it. And we will go straight to the demo, which Lihuy will show you. Yes.
Yes, I can you stop it now?
Yes.
Excuse me. Can you see my screen now, everyone? Can you?
I can see.
Yeah. Okay. Here. So here is what we present on the slide is our graphical user interface. Yes. As you can follow. Yes. So first we have to click this hamburger icon, which navigate us to the file selection. And then you can select your own file. So we have present some few experiment data set here for you. Yes. So the first one we will select yes, this one, which is our command license plate. And here you have information about the file. And then we will proceed to click the start button, which they will crop the license plate area for us. As you can see, this here is the crop license plate area and the recognition output. The recognition is near accurate because the license plate area is very yes, it's a present on plain sight for us, and the OCR can actually recognize it without any kind of noise and bad quality image. Yes, we also here is another one. Yes, again, as you can see, this one, because the license plate area is true, or yes, it's a teal, so it's Tesla OCR considered as a bad quality image or present with noise, so they only capture a portion of the they only recognize a portion of the text. Yes. Since we use a mixed license plate, we also can actually test a Western car image like this one present here. It capture almost yes, this one, because it's blurry, so the Tesla OCR also have this limitation that it cannot capture blur image. Yes, some of the limitation. Yes, also this one. Yeah, this one it's also one of the like failure case of our detection model, which we encounter. Yeah, this next one is also a Western car image. Yeah, this one capture perfectly, but because it's teal, also it's, as mentioned earlier, it's one of the limitation of the OCR. This one is a Cambodia car image. Yes, this one because yes, our detection perfectly capture the license plate area, and also the license plate area seem to be straightforward, and it's also there's no much noise or bad quality of the feature of the image, so the text OCR can recognize the text. Here is another Cambodia car image. Yes, again this one, because the car image yes, it's present as a whole image, and the text OCR can immediately recognize the text on the plate. This one is also similar to previous one. Yes. Yes, it's also nearly capture the plate text image, only subjugate to some noise and bad quality feature on the image. This is another one. Yes, this is one of the also failure case that mentioned earlier in the slide, like because this one is blurry and the text image is too small for the text OCR to capture it. Yes. This one is another car image. Yes, this one since our detection network only capture the part of the image, part of the license plate area, such as the number, so it can only recognize number. Yes. Yes, this is another car image. Yes, this one is one of the main limitation of the text OCR is its the environment constraint, such as the teal image, so it cannot text OCR have no capability to recognize it. This one is another image, a similar previous case. Yes, this one since it's fill nearly the entire image, so the OCR can capture immediately. Yeah, can recognize immediately. This one is another image. Yes, this one yes, it captures part of image correctly, but yes, because there seem to be blur. The image seems to be blurry, too small, and also some noise on background. Yes. And it's also part of the data set that we actually train, so it can recognize immediately since there's not much noise. And yes, also the quality of the license plate also very good for the text OCR to immediately recognize it. Western data set as well, Western car image. Yes, this one yes, it captured immediately, but somehow it's such as OCR cannot recognize it. Yes, it's also this is a part of limitation since it have no pre-processing capability to recognize it. You can also test on this one. Oh yeah, this is also a part of failure case that of our detection network. But it's perform. But the cropping of the license plate area seem to work on majority of the case. Only some few case. Yeah, this is the same one. This one is a new one as well. Yes, even through environment constraints such as the lighting condition and the position, it still capture correctly. And since it's a teal image, yes, it cannot capture it. I think that is. Yes, I think. Yes, I think we have a. I think we have a show you most of our test set. So, do you have any question? Everyone, you have any question? We show you all our the demo of our project. You have any question?
Hello.
Yes, hello, Miss.
Okay, so I have a questions. Right now, this project you can recognize a license plate of a car, right? So if you're
Yes.
going to kind of modify your project, your network to use for recognize a license plate for motorcycle, for example, motorcycle. So how what things that need to be re-implemented, or is that a lot of process or changing behind the
Uh,
scene? If yeah,
you mean to capture both car and motorbike plate?
yes, because your model is working for car, right?
Yes.
Yes.
Yeah.
We just have to collect
Motor
yes,
plate. Yes.
I think equally in size of the training data set for both a car and motorbike. Yeah, motorbike.
So
Yes, and then
it's in
yes,
terms of the model, you don't have to change it. It's you just need to collect motorbike data set.
Yes, Miss.
yes.
And
It. This is all. We have a state of art network or the work that train on this license plate only. Yes, we follow the original paper implementation.
so okay, so if I start training your model by feeding in license, I mean motorbike
Yes.
picture. So then eventually, if we have about, I think I remember from the presentation, you said about how many database, like a 1,000,
We
1,000.
have currently we have 3,000 data set only car.
Yeah. Okay. Okay, just good to know. And I think previously, the previous session, there's one speaker talking about his research that he is working in his master degree, and he also what he did in his research is about recognizing number of containers and number.
Container now.
As
Yes.
yeah, I don't know if you attend his sessions, but I was thinking when I was listening to his presentation, I was thinking about your project as well, because it's very similar idea, just only different applications. So his applications is scanning. It's just live feeding as well. That container, big container, semi container that carries stuff, have drive through uh, checkpoint or something, and they scan the label, and then they're able to detect what is a number. It's just like a license plate, but it's a number that they can check. So in what I, it's just asking you kind of if you're going to apply your model that you have here to different type applications, like what the example that I'm saying here. So you think is that how much work that you have to train a new your model for recognizing kind of another background, because when you're recognizing a license plate, the background is mostly is a car or something, but container label on a container is also a car too, but it's a truck, a big truck, something like that. You think is a kind of what kind of process or work that you have to do in order to move to the other application like this?
You mean aside from license plate to or to
Yeah.
other like other application aside from a car?
Yes. Based on what you already implemented and you're working already, but I'm thinking about if you're going to move it on to different applications like scanning a label on a container. A container here, I think is a semi truck, a big car, big truck that carry stuff in, and they usually have number. But it's not a license plate, okay? It's just a number for that container.
Oh, you mean
Yes,
recognize the number on it, Miss?
Yes.
Oh,
In
that
the
that
shipping.
that is another model. Because that is for recognition. For us, we only work on detection and classification.
But you also implement you detect, yes, and then you have the OCR, right? To recognize what number is it.
Yes.
yes, miss. The label on the container is similar to the plate or not?
Yes. That's what I meant. Yeah.
I
Do,
think,
do they have a sequence of character on it or not, Miss?
No, they have kind of a like a they have a camera that
Yes.
when they deliver shipments go out from a port like this, a lot of container moving in, right? So usually
Yes.
they would have a video that capture the label of the container. And
Oh,
then after they detect the label, they would scan and detect, okay, it's matched to what stuff that is kind of a register and
yeah.
what is inside the container connect to a database. Very similar to the license plate, what you are doing here.
Yes. We can transfer it, like because the
and to detect
yes, because our model.
if the label too small, it might be hard. If the label is similar to the plate size or bigger, we can train on that as well.
Oh, okay. So it depends on, okay, it's meant that if the
We
size
can treat it
label.
as an object. So yes, we can do that.
It's mainly depend on the data set.
Yeah. Okay. So it's mean that the model that you're building here can apply to different applications, but somehow if the size
Yes.
of if it's very close to the license plate, I mean the size of the labels and also the angles or the background very similar to what you're building here. So is the prototype probably able to transfer or deploy easily. But if even it doesn't matter, even if the size is different, it means you have to train the model more, I guess. Yeah.
Yes, miss.
Yes.
Okay.
Uh,
Yeah. Okay. Yeah. Thank you. I think other questions from other participants.
yes.
Yeah. I think if there is no further questions, you can also finish your presentations and get back at 3 o'clock if you want to have some fun and have a, group, playing game together later.
Yes.
Okay, so thank you both of you very much for your presentations.
Yes, thank you, Miss, and everyone for participating.
Yep, thank you. Yep.
Thank you.